Um, Today's lecture is about Milne Simpson's predictor-corrector method. This method is used to find the value of y for a specific value of x whenever a differential equation is given to you. What are the major steps for this method? The first one, a differential equation y prime is equal to function of x comma y will be given to you. Secondly, you will be given three starting values of y. Remember that you'll be given three starting values of y, because these methods, predictor-corrector methods, need three values of y to proceed with the next value of y. So these three values will be given to you. If these three values are not given to you people, then you need to use Picard, Taylor, Euler, or RK method to find these values of y. Thirdly, we need to find the corresponding value of y prime, which is actually the function of x comma y. And the fourth one is the step size, which will always be given to you people. And the most important is the use of predictor and corrector formulas here. So first of all, we need to use the predictor formula due to Milne. This predictor formula is due to Milne, and corrector formula will be due to Simpson's. So first of all, we will use the predictor formula to predict a certain value of y due to Milne. So how can we find that value of y? This is the formula: y n plus 1 is equal to y n minus 3 plus 4h divided by 3 into 2 f of n minus 2 minus f of n minus 1 plus 2 f of n, where n varies from 0 and so on. So that is the formula for due to Milne. That is called the predictor formula. And the second one is the corrector formula. The corrector formula due to Simpson will be used to find the value of y. What is the corrector formula due to Simpson's? That formula is yn plus 1 is equal to yn minus 1. This is the difference between these two formulas. Here is n minus 3 and here is n minus 1, plus that is 4h by 3, but this is only h by 3, and this is 2 f of n minus 2, and that is 2 f of n minus 1. There is negative sign minus f n minus 1, but there is positive sign for n. We see that is n minus 2, then n minus 1, then n. 1 is increased in these suffixes. Similarly, 1 is increased in these suffixes or subscripts, you may say that. So remember that this one starts from n minus 2, then adding 1 to this 2 minus 2, so that will be minus 1, then n. And in this formula, that is 2fn minus 1, increase 1 here, so that will be fn, and increase 1 more here, so that is fn plus 1. So these are the major differences between these two formulas. These calculations are very simple, but the most important thing is to compare these two values of y. If these two values of y are nearly equal to each other, or if you are asked to find the value of y up to 4 decimal places, so the values of these two must be equal to 4 decimal places, up to 4 decimal places. If you are asked to find the answer up to 5 decimal places, so these two values of y must be equal to each other up to 5 decimal places. Anyways, so if the two values of y, that is the same sentence that I am repeating here, if these two values of y obtained from predictor and corrector are nearly equal to the required accuracy, that accuracy may be up to 4 decimal places, maybe up to 5 decimal places, whatever the question is. So required accuracy, then stop the calculation, and the answer will be the same which is obtained from these two formulas. Otherwise, this is an important one, otherwise continue using corrector formula, this one, continue using this corrector formula to get the required accuracy. We need to repeat this corrector formula again and again to get the required accuracy, not this predictor formula but this corrector formula. So these are the major steps for Milne Simpson's predictor-corrector method. Let us start an example to check whether how can we solve question on this method. Example is by using Ranji-Katta method, the solution of y prime is equal to x minus 1 with initial values 0, 1. These are the initial values. Initial values mean that is x naught and this is y naught. Initial condition gives the following set of values. This differential equation is solved by RK method with this initial condition, and the following set of values is obtained. These are the values of x and these are the values of y. So this table is given to you. The question is, use Milne-Simpson predictor-corrector formula to find y of 0.4, to find the value of y at certain value of x which is 0.4. Remember that this is x, so this is the value of y. This value of y is actually y of 0.0. This value of y is actually y of 0.1. This value of y is y of 0.2, and similarly this is y of 0.3. We need to calculate y of 0.4, which is the upcoming value here, y of 0.4 here, correct to 4 decimal places. So remember that whenever you use predictor and corrector formulas, you need to check the answer up to 4 decimal places. If the two values of y are equal to each other up to 4 decimal places, then we need to stop there, and the answer is that one which is obtained from these two formulas. So the solution is differential equation is given to you, y prime, which is always denoted by a function of x comma y, and that is given to you x minus y, that is x minus y. So function of x comma y is x minus y. So from here add the suffix n in all these variables. Subscript, put a subscript n here, n here, n here, and n here, and there as well. So there is function of x n y n is x n minus y n. That is given to you, people. Secondly, initial value is given to you 0 comma 1. 0 comma 1 is given to you. Compare 0 comma 1 with x naught comma y naught. We'll get x naught equal to 0 and y naught equals to 1. So these are the initial values. Now just look at this table. Start n from 0, because n starts from 0. 0, 1, 2 and 3 here. 0, that is 1, that is 2, that is 3. And xn, so whenever n is 0, so that will be x naught. X naught is 0.0. Whenever n is equal to 1, so that is x1, and x1 is 0.1. Similarly, x2 is 0.2, x3 is 0.3. That is from the given table. So these are the values of xi's. And the third column is yn. Y naught, that is the value of y naught, 1.0000. Y naught is actually y of x naught, y of 0.0. Remember that this y naught is actually y of 0.0. y1, this is y1, 0.9097. This y1 is actually y of 0.1. Similarly, this is y2, this is y2. y2, which is this thing, that is actually y of 0.2. Similarly, the last value is y3. This is 0.7816. This is y3, so that is y3, and y3 is actually y of 0.3. These are the values of y. Now the third step that we have studied, that calculate the corresponding value of function. That is the function of x n y n, which is x n minus y n. Function of x n comma y n is represented by fn. You can denote this function by fn, which is equal to x n minus y n. This is just a notation. Fn is actually f of x n comma y n. So fn is equal to x n minus y n. Whenever we put n is equal to 0, so that will be f naught equals to x naught minus y naught. X naught minus y naught, that is x naught, which is 0.0. You may say that that is 0, and minus y naught. Y naught is actually 1.000, actually 1. So that is 0 minus 1. 0 minus 1 is minus 1.0000. We use here the numbers up to 4 decimal places, because we are dealing with 4 decimal places. 4 decimal places, remember that. So write all those numbers up to 4 decimal places. Secondly, f1 will be equal to x1 minus y1. So x1 minus y1, that is x1 0.1, and that is y1. So f1 is equal to x1 minus y1, and that is minus 0.8097. Similarly, f2 will be equal to x2 minus y2, x2 minus y2, and that is x2, and this is y2. So x2 minus y2 is equal to this thing, and the last one is, that will be f3. f3 is equal to x3 minus y3, that is x3, and this is y3. So f3 is equal to this thing. So that was the first step to calculate the corresponding value of the function. So we have obtained all these values of the function. Now we are ready to use a predictor formula to find y of 0.4. Y of 0.4 will be upcoming value, which is actually y4. So whenever we use predictor formula first, that is the predictor formula. So we need to find y4 here, y4. So what will be the value of n to get this thing y4? That is 3. That is 3. Whenever we put n is equal to 3 here, we will get y4. So put n is equal to 3 in this formula. Whenever we put n is equal to 3, we will get this equation. That will become y4, that will become y0, that will become f1, that will be f2, that is f3. So that is y4, which is this thing. Now from table put the values of y0. This is y0, and we see that h is 0.1 from table, because x0 is 0.0 and x1 is 0.1, x2 is 0.2. so the gap, the step size is here 0.1. so h is 0.1. replacing h, replacing f1 from table, replacing f2 from table, replacing f3 from table, and calculate this sum. We will get 0.7407. that is the value of y4. Now for this y4, calculate the value of the function. We know that fn is equal to xn minus yn. So for y4 we need to put n equal to 4. We will get f4 is equal to x4 minus y4. So x4 is 0.4 and y4 is this value 0.7407. so replacing y4 and subtracting these two, we will get f4 equal to minus 0.3407. now using corrector formula due to Simpson, that formula is due to Milne, predictor formula, and corrector formula is due to Simpson, so that is the predictor corrector formula. Now we need to find y4. so at the same way we need to put n is equal to 3 in this equation to get y4. so put n is equal to 3. whenever we put n is equal to 3, we will get this equation. That will become y4, that will become y2, because n is equal to 3. that will become f2, that will become f3, and that will become f4. so that is f4. From here we need to put f4 in this formula, so that's why we have calculated f4 here. So putting all these values from table, the value of y2 from table, the value of h 0.1, the value of f2 from table, the value of f3 from table, and the value of f4 is from here, this value minus 0.3407. that is the value of f4. Now calculating this thing, we will get 0.7407. that is the value of y4. Now just look at these two values of y4. This is the value of y4 which is obtained by using predictor formula, and this is the value of y4 obtained by using corrector formula. If you compare these two values of y, this value of y and this value of y, these two values of y agree up to 4 decimal places. These are same up to 4 decimal places. So we say that the value of these two y4 obtained from both predictor and corrector formula agree up to 4 decimal places. So therefore y4 is actually y of 0.4. I told you before, that is y of 0.4, and this is actually 0.7407. So that is the criteria to use Milne Simpson's predictor-corrector formula to find a certain value of y for a given value of x. I hope this is a very simple method to understand and to use. You just need to match these two values of y obtained from predictor and corrector formula. If these two values of y agree up to a certain decimal places, so that is the required answer. Now here we see that we need to calculate the answer up to 4 decimal places. So it will be suitable for we people that we need to fix our calculator up to 4 decimal places. This is not necessary to fix our calculator, but for the purpose of calculation, for the purpose of comfort, we need to fix the calculator up to 4 decimal places. How could we fix the calculator up to 4 decimal places? We have got this mod or setup button, and we see that setup is just like shift. So press shift, then setup. We see here that fix is associated with 6. So press 6. It will ask you people that fix this calculator up to how many decimal places. So fix it up to 4 decimal places. If you want to fix this calculator up to 5 decimal places, then press 5. If you want to fix up to 6 decimal places, then press 6. But we need here to fix the calculator up to 4 decimal places, so press 4. Now your calculator is now fixed up to 4 decimal places. Now we need to enter this function in the calculator, which is actually x minus y. So the function, this is f, denote the function by f or e, whatever you want to use. So f then is equal to the function is actually x minus y. This is x minus y. So enter this function in the calculator, x minus y, that is x minus then y. So this function is now inserted in the calculator. You just need to press the calc button. It will ask you about the value of x. You see that the value of x is up to 4 decimal places, because we have fixed this calculator up to 4 decimal places. So what is the value of x? The starting value of x is 0.0. So say that 0.0. Then press equal button. It will ask you about the value of y. The value of y is 1.0000. So that is 1.0000 is equal to. So the function is minus 1.000. You see that minus 1.000 and 0. Then press this equal button. It will ask you about the value of x again. Now the value of x is 0.1. So press 0.1, then equal button, asking about y. So y is actually now 0.9097, that is 0.9097. so that is equal to minus 8097 by 10,000. Convert this into decimal places. Minus 0.8097, so that is minus 0.8097, and this is up to 4 decimal places, because we have fixed this calculator up to 4 decimal places. Now again press this equal button, asking about x. Now the value of x is 0.2, so that is 0.2. Now press equal button, asking about y. The value of y is 0.8375. so that is 0.83 and 5. Now press equal button, you'll get minus 51 by 80, so that is minus 0.6375, so there's minus 0.637 and 5. Now again press this equal button, asking about x. X is now 0.3, so that is 0.3. Press equal button, asking about y. So y is 0.7816, that is 0.781 and 6. Now press this equal button, you'll get this number, and that is actually minus 0.481 and 6. So this is how we use the calculator to find these values of the function by fixing our calculator up to 4 decimal places.